What's going on, everyone? Welcome back. Moving on to another question dealing with infinite limits. We have to find these two limits here. So the limit as x approaches pi over 2 from the negative side of ln of cos x, and then the limit as x approaches pi over 2 from the positive side of that same function, ln of cos x. So first thing, notice that we can't directly sub in pi over 2 here because cos of pi over 2, as we know, is 0. And then ln of 0 is undefined. Okay, so that's going to be a vertical asymptote there. So we can't plug in pi over 2 directly. So what we're going to have to do is approach pi over 2 from both the left side and the right side. Pick numbers that are very close to it. So starting here, approaching it from the left side, from the negative side, problem is pi over 2, that's like an exact value. So what we want to do is we want to get the decimal value of that. And if you take pi over 2, if you plug it into your calculator, you'd end up getting something like 1.57079 if you round to 5 decimal places. There's more decimals, but I'm going to just keep it to 5 decimal places for this example. And so now that it's in decimals, it's kind of easier to pick x values where we approach it from that left side. So notice that the last two figures are 7, 9. So how about we choose something like 075? That's pretty close to the left of this number. And then we could even get closer, 1.57078, let's say. And if you take those values and you plug them into this function, making sure that your calculator is in radians, you get these respective y values here. So just from these y values, you could tell that the y values are going towards what? Negative infinity. And so that is the answer for this first limit here. Now, what about the limit as we approach pi over 2, or this decimal value, but from the right side, from the positive side? So if you make a table of values for this, so a number that is to the right of this would be like 80 at the end, or maybe 81 at the end. Let's pick 80, it's closer. So 1.57080, and then we don't have to write that last 0. So 1.5708 is to the right of this value here, of this number. And notice that if we take this and we plug it into this function, what we're going to get in the calculator is an error. Right? And so basically the answer to this is that the limit does not exist as we approach pi over 2 from the positive side. Now, why is that? Well, if you remember from the last video, I mentioned that whenever you have ln of an expression, the domain for that function is always going to be when the expression is greater than 0. Because we can't be lnning 0, or we can't be logging 0. It doesn't have to be ln necessarily. It could be log with any base. We can't be lnning 0, and we can't be lnning a negative number. That's always going to give us an error. And so cos x, if we graph it, and more specifically, if we look at what's happening at pi over 2, this graph here is cos x, notice that as we approach pi over 2 from that left side, notice that all of the y values are going to be positive there. And so what's going to happen is they're going to be positive, but they're going to be really, really small. So whenever you're lnning a small positive number, the y values are going to go towards negative infinity. Because if you remember, ln x in general looks like this. So any of those values that are small but positive, the y values are going towards negative infinity. But notice that if we approach pi over 2 from the right side, those y values then are going to be close to 0, but they're going to be negative. And you can't be lnning a negative number. Now, another thing I want to mention is you didn't necessarily have to do this in radians. You could also use degrees. You could put your calculator in degrees, and here you could put like pi over 2 is like 90 degrees. So you could put 89.9, 89.99, etc., etc. You'll see that the y values go towards negative infinity. And over here, if you try numbers like 90.01 or 90.001, etc., etc., if you take those numbers, plug it in here, when your calculator is in degrees, you'll get an error. Because again, any values greater than pi over 2, around pi over 2 that are greater, are going to be negative, and you can't be lawning a negative number. And so again, that's the reason why this limit goes towards negative infinity, but this limit here does not exist.